Okay, in this session we're going to have a look at Unit 4, Chapter 4, Trigonometry and the Unit Circle. We're looking at trig ratios, and we'll be looking at finding trigonometric ratios for special angles of rotation. Okay, the focus of this lesson will be on relating the trigonometric ratios to the coordinates of a point on the unit circle and determining exact values of trigonometric ratios. Okay, I want to recall the primary trig ratios. The primary trig ratios are sine theta, cosine theta, and tan theta. You should also remember that tan theta is equal to sine theta over cosine theta. We also have the reciprocal trig ratios, which are cosecant theta. Cosecant is the reciprocal of sine, so it's 1 over sine. Secant is the reciprocal of cosine, or 1 over cosine. And cotan, which is the reciprocal of tan, can be written as cosine over sine. You need to memorize and know your reciprocal trig ratios, and also you need to know that tan is equal to sine over cosine. I want you to recall as well that any point on the unit circle can be represented as cosine theta comma sine theta. So if I take any point on the unit circle, that point xy can be represented as the cosine of the angle and the sine of the angle. The angle meaning the angle of rotation from the positive x-axis. So here's my angle of rotation of theta. The coordinates of that point on the unit circle is cosine theta, sine theta. I also want you to recall this very important table that you see here. If you have a reference angle of 30 degrees, or pi over 6, there's a point associated with that reference angle, and it's root 3 over 2.5. If the reference angle is 45 degrees, or pi over 4, the point associated with that reference angle is root 2 over 2 and root 2 over 2. And a reference angle of 60 degrees, or pi over 3, has the point 1/2 and root 3 over 2 associated with it. Notice that these two are very similar in that this one is root 3 over 2.5, whereas this one is 1/2 and root 3 over 2. Here's how I remember it. The 30-degree reference angle begins with the 3, the root of 3. But I just remember it's root 3 over 2 and 1/2. The 60-degree reference angle doesn't begin with the 3, it begins with 1/2. You need to come up with a strategy that will enable you to remember the point and the reference angle associated with it. But they're very important. Okay, let's have a look at some examples now. Determine the exact value of each. Draw diagrams to illustrate your answer. And you see we have 6 different ones here to do. I've chosen a variety of degrees and radian measures. I've looked at positive angles of rotation, negative angles of rotation, and I've looked at all 6 trig ratios: sine, cosine, tan, secant, cosecant, and cotan. Let's do them. I'm looking for the cosine of 5 pi over 6. Let's draw a diagram here. 5 pi over 6. Here's my unit circle. Now, 5 pi over 6, you need to think about where 5 pi over 6 is located. Well, this is 6 pi over 6 here, which is pi. 5 pi over 6 is 1 pi over 6 less than that, so that's right here. Reference angle, very important. Reference angle here is pi over 6. Pi over 6. And the point associated with a reference angle of pi over 6, which is 30 degrees, is root 3 over 2 and 1/2. Now, of course, in this quadrant, x is negative and y is positive. We need to be very careful with our signs here as well. So a reference angle of pi over 6, the point associated with that is negative root 3 over 2 and 1/2 in this quadrant. We're looking for the cosine of the angle. The cosine of the angle is going to be the first coordinate. Now let's go back here again. You see any point on the unit circle can be represented as cosine theta, sine theta. So the first coordinate represents cosine, the second coordinate represents sine. My reference angle again of pi over 6, root 3 over 2.5. That's where all this is coming from. You need to know what's on the previous slide. So the answer, of course, is simply negative root 3 over 2. Negative root 3 over 2. Let's do the next one. The sine of negative 4 pi over 3. Again, we need to draw a diagram to do this. Draw a unit circle right here. Negative 4 pi over 3. Now we're rotating in the negative direction. And we need to go negative 4 pi over 3. So this here will be negative 3 pi over 3. This is negative 6 pi over 3. I want to rotate negative 4 pi over 3. So I'm going to rotate negative 3 pi over 3 and another 4 pi over 3, which is another 60 degrees, and my terminal arm is going to be located right here in this case. And again, note the reference angle. I've got another another pi over 3, so the reference angle is pi over 3. If the reference angle is pi over 3 or 60 degrees, I know the point associated with that reference angle now. 60 degrees, the point associated with that is 1/2 and root 3 over 2. Note it's still in the second quadrant, so x is negative. I'm looking for the sine of negative 4 pi over 3. Sine is the second coordinate, not the first, so it's a positive root 3 over 2. Positive root 3 over 2. So I've rotated negative 4 pi over 3, recognize that my reference angle is pi over 3. Knowing that my reference angle is pi over 3, I know the point associated with that is 1/2 and root 3 over 2. In quadrant number 2, of course, x is negative, y is positive, sine is the second coordinate, root 3 over 2 is my answer. Tan of 2tan. Let's do this one next. I'm going to draw my unit circle again. 210 degrees, we're rotating in the positive direction, 210 degrees. 210 degrees will be right here, approximately. The reference angle, of course, which is the most important part of any of this, is finding the reference angle. The reference angle here, which is theta r, would be 30 degrees in this quadrant, because we've rotated 180 plus 30. So the reference angle here would be 30 degrees. If the reference angle is 30 degrees, then the coordinates of the point associated with a reference angle of 30 degrees is root 3 over 2 and 1/2. In quadrant 3, both are negative. We need to remember our signs. I'm looking for the tan of 2tan. The tan of 2tan is equal to the sine of 2tan over the cosine of 2tan. The sine of 2tan is the second coordinate, which is negative 1/2, divided by the cosine of 2tan, which is a negative root 3 over 2. If we divide that out, we will get negative 1/2 times 2 over a negative root 3, which will equal 1 over root 3. We don't leave a radical in the denominator, so we're going to multiply by root 3 over root 3 to get a final answer of root 3 over 3. There is the sine of 210 degrees. The tan of 210, which is sine over cosine. So I found the sine of 2tan divided by the cosine of 2tan, and I simplified it to get a positive root 3 over 2. And it makes sense that tan is positive in this quadrant as well. Because of the CAS rule, we know that tan is positive in that quadrant. Okay. D. The secant of 315. Draw my diagram again at 315 degrees. Construct my unit circle. (315 degrees), positive direction, we're rotating 315. It's going to bring me approximately right here. It's in the fourth quadrant, 315 degrees. The reference angle is the angle measured from the positive x-axis, and the reference angle in this case is going to be 45 degrees. That's your reference angle. If I know the reference angle is 45, I know the point associated with a reference angle of 45 is root 2 over 2 and root 2 over 2. Of course, in this quadrant, x is positive and y is negative. I'm looking for the secant of 315. Secant is the reciprocal of cosine. So it's 1 over the cosine of 315. The cosine of 315 is the first coordinate. The reciprocal of the first coordinate, root 2 over 2, take the reciprocal of that, I'll get 2 over root 2. I don't leave a radical in the denominator, so I'm going to multiply by root 2 over root 2 to get an answer of 2 root 2 over 2, which simplifies to simply root 2. Root 2. 2 root 2 over 2 is simplified to root 2 because, again, the 2's will cancel here, of course. So there's how we found the secant of 315. Now we've got to do the cotangent of negative 225. So again, I'm going to draw negative 225 here. Let me create my unit circle quickly. Negative 225, rotating in the negative direction, 225 degrees. That's negative 180, and I need to go another 45 degrees beyond that to get to negative 225. So there's negative 225. The important thing is the reference angle. The reference angle is 45 degrees. The reference angle is the angle from the terminal arm to the x-axis. If I got a reference angle of 45 degrees, I have a point, negative root 2 over 2, and negative root 2 over 2. Cotan is equal to cosine over sine. So it's the cosine of negative 225 over the sine of negative 225. Cosine over sine will be negative root 2 over 2 divided by root 2 over 2, which of course is negative 1. The cotan of negative 225 is negative 1. And last, let's have a look at the cosecant of negative 5 pi over 3. Draw my unit circle yet again. Negative 5 pi over 3. I'm rotating negative direction this time. This is negative 3 pi over 3. This is negative 6 pi over 3. I want to rotate negative 5 pi over 3. Negative 5 pi over 3 will be 1 pi over 3 less than 6 pi over 3. So my terminal arm is going to be located approximately here. That's a rotation of negative 5 pi over 3. I'm 1 pi over 3 less than 6 pi over 3. Reference angle is pi over 3, which is 60 degrees. A reference angle of 60 degrees, the point associated with that is 1/2 and root 3 over 2. I got to know those points associated with each reference angle. Cosecant is 1 over sine. So I'm looking for the 1 over the sine of negative 5 pi over 3. The sine of 5 pi over 3, or negative 5 pi over 3, sorry, sine is going to be root 3 over 2. So the reciprocal of that would be 2 over root 3. Of course, I don't leave a radical in the denominator, so I'll multiply by root 3 over root 3, and I get 2 root 3 over 3. And there's my answer for the cosecant of negative 5 pi over 3. So I've looked at an example of each: sine, cosine, tan, secant, cosecant, and cotan. Looked at radian measure, degree measure, positive angles of rotation, and negative angles of rotation. Here's another example. It might be a good idea at this point now, after seeing the last example, for you to pause the recording and try this one on your own before I actually do it. Okay, it says, what is the exact value of the sine of 7 pi over 6? Let's rotate 7 pi over 6 first of all. I'm just going to draw my circle, move it around here so that it's appropriately located. There we go. 7 pi over 6. I'm rotating in the positive direction, 7 pi over 6. This is 6 pi over 6. This is 12 pi over 6. If I rotate 7 pi over 6, that is 1 pi over 6 more than 6 pi over 6. So my terminal arm is located here. That's 7 pi over 6. Of course, the reference angle is pi over 6. If the reference angle is pi over 6, which is 30 degrees, the point is going to be root 3 over 2.5. In this quadrant, both are negative. I'm looking for the sine. The sine is the second coordinate, so it's negative 1 over 2. Answer is B. Sine is the second coordinate, cosine is the first coordinate. Excuse me. Sorry for that. Example 3. Show that the exact value of the cosecant of pi over 3 plus the cotan of 11 pi over 4 is 2 root 3 minus 3 over 3. So I'm trying to get the exact value of the sum of those two there. So let's do them individually, and then let's add them. We're looking for the cosecant of pi over 3. And we're also looking for the cotangent of 11 pi over 4. So I'm going to draw a separate diagram for each. Always a good idea to draw diagrams for all of these. And we're going to rotate pi over 3 first. Pi over 3 is 60 degrees, right there approximately. Reference angle is clearly pi over 3 or 60 degrees. 60 degrees, I know the point associated with 60-degree angle is 1/2 root 3 over 2. I'm looking for the cosecant of pi over 3. Cosecant is 1 over the sine of pi over 3. The reciprocal of sine, there's the sine of pi over 3 right there. The reciprocal of root 3 over 2 is 2 over root 3. I'm just going to leave it like that for now. Just for now. We'll change it shortly. So I have 2 over root 3 for the cosecant of pi over 3. Now let's do the cotangent of 11 pi over 4. 11 pi over 4. This is 4 pi over 4. This is 8 pi over 4. If we continue to rotate, 4 pi over 4, 8 pi over 4, if I went all the way around to the 180-degree mark again, that would be 12 pi over 4. I don't want to go to 12 pi over 4, I want to go to 11 pi over 4. So my terminal arm is going to be pi over 4 less than I've rotated. So my terminal arm is located right here. That would stop there, and now I have a rotation of 11 pi over 4. But again, the important thing is my reference angle is 45 degrees or pi over 4. If I know the reference angle is pi over 4, I know the point associated with that is root 2 over 2 and root 2 over 2. X is negative in this quadrant, y is positive. I'm looking for the cotangent of 11 pi over 4. The cotangent of 11 pi over 4, I'm just going to write this out here for you. The cotangent of 11 pi over 4, cotangent is equal to cosine over sine. So it's the cosine of 11 pi over 4 divided by the sine of 11 pi over 4. Sorry. Fix that. Cosine divided by sine is a negative root 2 over 2 divided by root 2 over 2, which is negative 1. Okay, I've now found the cosecant of pi over 3, and I found the cotangent of 11 pi over 4. I need to add the two together, and I should get this answer when I add them together. Let's proceed to do it. I got 2 over root 3 plus a negative 1, or subtract 1. Let's get rid of our radical this time. 2 over root 3, I'm going to multiply by root 3 over root 3 to give me 2 root 3 over 3, subtract 1. I need to find a common denominator here of root of 3, so I got 2 root 3 over 3, subtract 1, which is 3 over 3. Now I have a common denominator of 3, and my numerator becomes 2 root 3, subtract 3. And I do have the correct answer, because you can see that I was asked to show that it was equal to this. So the exact value here is 2 root 3, subtract 3 over 3. Exactly what I found. Okay, I think we have one more example left. Find the exact value of this trigonometric expression. Secant of 2 pi over 3 times the tan of negative 5 pi over 4 divided by 2 times the cosine of 11 pi over 6. We have to find each of these individually first. So I'm going to draw 3 diagrams, one for each of the trig ratios. Here we go. Now then, the first one is a rotation of 2 pi over 3. 2 pi over 3, just think about this as being 3 pi over 3. I'm 1 less than that, so I'm pi over 3 less than that, which is 60 degrees less than that. So this is a 60-degree angle right here, or pi over 3. Now, the point associated with a reference angle of 60 degrees is 1/2 and root 3 over 2. Don't forget, in this quadrant, x is negative and y is positive. We'll find the secant in a second. Let's go over and do negative 5 pi over 4 in my next diagram. So I'm rotating in the negative direction this time. This is negative 4 pi over 4. I'm 1 beyond that, so I'm going to be in this quadrant again. So the reference angle this time, though, is pi over 4. That would be a rotation there of negative 5 pi over 4, just as this was a rotation of positive 2 pi over 3. In this quadrant, reference angle pi over 4, I got a negative root 2 over 2 and a positive root 2 over 2. That's the coordinates of my point. And finally, 11 pi over 6. This is 6 pi over 6. This is 12 pi over 6. So 11 pi over 6 is 1 pi over 6 less than 12 pi over 6, which is approximately here. So there's my rotation of 11 pi over 6. My reference angle, of course, is pi over 6, or 30 degrees. A reference angle of pi over 6, 30 degrees, gives me a point, root 3 over 2 in this quadrant, and negative 1/2. Okay, now that we have our 3 points, we should be able to quickly determine the secant, the tan, and the cosine of each of them that we need. Let's do that. Here we go. The secant of 2 pi over 3. Secant is the reciprocal of cosine. The reciprocal of cosine is negative 1 over 2. The reciprocal of cosine will be negative 2 over 1, or simply negative 2, times the tangent of negative 5 pi over 4. Here's negative 5 pi over 4 right here. The tangent of negative 5 pi over 4 is the sine of 5 pi over 4, or negative 5 pi over 4, divided by the cosine of negative 5 pi over 4. Sine divided by cosine should give you, and you should recognize this, negative 1. And again, if we need to do that, I suppose I can. The tan of negative 5 pi over 4 is equal to the sine of negative 5 pi over 4 divided by the cosine of negative 5 pi over 4. Sine divided by cosine is going to be a root 2 over 2 divided by a negative root 2 over 2, which is equal to negative 1. Anything divided by itself is 1, so here it's, of course, negative 1. Divided by 2 times, let's see what we get this time, the cosine of 11 pi over 6. There's 11 pi over 6. There's cosine, so I got 2 times root 3 over 2. Cosine is going to be the first coordinate, isn't it? So we get root 3 over 2. Okay, let's simplify it. Negative 2 times a negative 1 is 2. Over 2 times root 3 over 2, you should recognize that as simply being root 3. Multiply by root 3 over root 3, and you will get 2 root 3 over 3. There's my final answer for the exact value of that expression, 2 root 3 over 3. Okay, summary of key ideas here. Let's have a look at these. Points that are on an intersection of the terminal arm and an angle theta in standard position and the unit circle can be defined using trig ratios. P of theta equals cosine theta comma sine theta. Each primary trig ratio, sine, cosine, and tan, has a reciprocal trig ratio, cosecant, secant, and cotan, and here they are. You can determine the trig ratios for any angle in standard position using the coordinates of the point where the terminal arm intersects the unit circle, and the exact values of trig ratios for special angles, such as 0, pi over 6, 4 pi over 3, pi over 3, and pi over 2, and their multiples can be determined using the coordinates of the point on the unit circle. And that ends this lesson.